Hello. As announced earlier, today we are going to talk about another method, RandomForest. What is RandomForest? It is a powerful machine learning algorithm that is used for classification and regression tasks. It is what French call an ensemble or combined learning method that brings together multiple decision trees to improve accuracy and prevent overfitting. So in regression tasks, RandomForest averages the results of multiple trees to provide a robust prediction. The main breakdown of it are decision trees. It builds multiple decision trees using different subsets of the training data. The one that we are going to feed to the model with the data files we gathered from getData method. And each tree makes prediction based on the pattern it finds in the data. Ensemble learning, by aggregating the prediction of multiple trees, RandomForest reduces the risks of overfitting, where the model becomes too tailored to the training data, and produce more reliable prediction. And feature selection, at each node of the decision tree, RandomForest selects a random subset of features to consider for splitting the data. The randomness helps the algorithm generalize the data. In context of stock price prediction, where we're going to use it, RandomForest is useful because it can capture non-linear relationship as opposed to the linear regression model. And it's important for understanding the various market conditions might affect future prices. Once again, neither linear regression nor RandomForest or any other model doesn't give you 100% accuracy. It just analyzes the data and tries to predict patterns, but as the word prediction concludes on itself, there's no guarantee that it will be successful. What does it provide? It provides a prediction method and results which you can observe, understand how precise it is, and let me actually bring one more time the Excel file which I showed you earlier lessons. Here you can see 6 methods: XGBoost, RNN, neural network. This will be the part of our next exercise. RandomForest, linear regression, LSTM, and ARIMA or ARISMA. And this is the blended value based on their prediction. You can see that for different days the prediction percentage in terms of MSE and MIAE and also MAPE is varying, like 60%, 80% of predictions were right. This one says that 100% were right, but going above we can see that it goes down to 40 or even less. So something happens and actual stock price, for example, for SPY goes down and suddenly it's throwing a wrong calculation. No big difference between the stock prices for Meta or Google, but again, RandomForest delivers wrong prediction. So again, it's not a guarantee. With that being said, let's talk a minute about what our code will do on a high level. Our code will get the data from CSV files from the data folder. One CSV file for each stock. We saw how those files were generated. It will pre-process the data by converting dates, scaling prices, and preparing datasets. Then the model will be trained on historical stock data, and the trained model will be saved on the disk in here in models RandomForest data, and this process will be repeated for every stock from the dataset. So that being said, let's move forward to actual coding. Again, we start with the import, and let's just copy and paste all the import that we made for linear regression, but with small adjustment. Instead of linear regression, we are going to use RandomForest regressor. It's not a linear model, it's ensemble. Okay, we mentioned why what we are importing and why. Again, NumPy for numerical operations, pandas for dataset and manipulating CSV files for the stock data, min-max scaler for scale the stock price between 0 and 1. As for linear regression, RandomForest regressor, it is our machine learning model. Joblib is to save the files for future use, and OS to handle operations with the file system. We can copy again the data directory, model directory, and OS make directory, and adjust it a little, or even include the one above, and just paste it. Just here we are going to use RandomForest. Here we specified the base directory, which is the root, and next we specified the data directory, the model directory where all models will be saved, and the option to make directories to ensure that it's created if it doesn't exist yet. Now next goes the dataset function. Dataset creation will be the same as for the previous model. So we will just copy and paste it here. Let's just have Control Alt L to align the code. Next, we are going to train and save the model for each of stocks. Let's do that. For file in list directory, data directory, do the following: if file ends with we're selecting CSV files, symbol is the file split dot and first column. Print processing file for stock and symbol. We can see that it automatically became an F string. And data will be pandas read CSV os have join data directory and file. So we are looping through the files which have the CSV extension in the data directory, and we are loading the CSV files using the pd read CSV file. Now next comes validation of the data. We are checking if the data is not empty. If data is empty, print all data available for symbol and continue. All this under the for statement. And next we will pre-process the data. Data date equals pandas to datetime data date. Next, data set index date in place equals to true. The same basically which we did for linear regression model. Here we go. And after that, we are going to drop all the values that doesn't contain the data. Drop an A in place equals to true. Now let's talk about this little part. We convert the dates, the date column, to the correct datetime format. We set the date as an index, and we are dropping here the missing values. Now another check will be to see if the data file is empty. If data empty, or we don't have enough data to start our model working on it, so the number of days for which we have data is less than 100. We are checking that by the length of the data, less than 100. Print insufficient data or symbol, and once again continue. Now it's time to calculate the moving averages. Let's create that indicator. MA100 is data, close, and you remember we did it with rolling and 100 as parameter, or the length, and same way we're going to do for the MA200. Change it 100 and here. And now the time of the random forest approach. Now we are splitting data into train and test sets. Train size equals integer length data multiplied by 0.8. I'll get back to this in a minute. Train data equals the data of train size, and test data will be equal to the data purely train size. If train data empty or test data empty, print insufficient data to process, and continue. Let's go over this section for a second and explain it. Now we define the train and test split for the ratio of 80 to 20, where the 80% will be the training data and 20% will be testing data. This will ensure that the model is trained on the majority of data and evaluated on unseen or test data. So we are training it on 80%, and the remaining 20% is to evaluate if some patterns or some actionable items are missed and the model didn't count those. Next we'll go our scaler part. So we gotta scale this data in the set of from 0 to 1. Scaler equals min max scaler, feature range equals from 0 to 1, train scale will be scaler transform train data close, and the test scale will be the same for the scope of the test data. Once again, what we are doing here, both the training and test datasets are scaled to values between 0 and 1, which is important because machine learning algorithms perform better when the data is normalized. So we are normalizing the data. Next, and bear with me, we have got very little part of the code remaining. Now we will prepare training and test sets. X train, Y train equals to create dataset on train scale, and X test, Y test will be the same but for test scale. And one more check, if the set is equal to 0, we will just skip it. If X train size equals to 0 or Y train size equals to 0, print, let's make this one shorter, skipping, continue. Now this will help us to avoid checking the stock symbols for which we don't have enough data to train our models. Now we will go to the models themselves. RF model is RandomForest regressor and estimators equal to 100, and RF model fit for X train and Y train. Here the RandomForest regressor initializes the model with 100 decision trees, and estimators is the parameter responsible for that, and then we are training the RandomForest model on a training dataset. The model will learn how to predict future stock prices based on the past 100 days of the data. And finally, to operate with files and save the data, job lib dump RF model model directory, symbol dot ref tk print model symbol saved as symbol f.pkl. Now the final part of our code saves the model in a directory. We provided a pattern for it, the model directory, and each trained model will be saved as a file with the stock symbol name and rf at the end of file name and pkl for the extension. So this completes the code. Let's go one more time over what we achieved. Again, on a high level, import, providing the directory for our operation with the operating system, creation of dataset, and then going over the CSV files, which is one file for each of stock symbols. We are making different checks to avoid operating on empty data or empty file. Then we pre-process the data by converting the dates, by scaling the prices, and by preparing datasets. Next, the RandomForest model is trained with creating a training material scaled and test scaled dataset and applying dataset creation. Then RandomForest model works on a depth of 100 decision trees, fits into with the model of X-train and to the training data, and after that every and each of model files is saved in a provided pattern or to the directory with the stock symbol name as a file name and pkl as an extension. And in our Streamlit app we can see that we are doing checks whether it's neural network, random forest, or linear regression selected, to which case we operate with each file. And in particular for random forest part, we can see here that we are going to provide the name of the file as a stock symbol and rf.pkl as a file name. This concludes today's session, and tomorrow we will go over neural networks and hopefully we will complete it. Then we will go for a couple of sessions for executing the whole flow end to end and seeing results displayed. Hope you liked the video. Subscribe to channel to not miss anything which you might like but can't see. And thanks for watching and subscribing. See you next time. Bye bye.